Alright, so let's take on the situation here where the child is kicking the soccer ball off of the roof, and I'm going to say that this is a very gifted child, because 61 meters is quite a kick. But anyways, let's go through this. Frequently it's helpful with these problems to divide things up, and we'll do a horizontal direction and a vertical direction just to keep things separated out. So let's look at the information they give you. So the soccer ball is kicked at 47 degrees from the edge of the building at an initial velocity of 17 meters per second. So that is 17 meters per second, and that means that that velocity will have x and y components initially. So the vertical component would be 17 sine of theta, and the horizontal component would be 17 cosine of theta. Now, and it tells us that the ball lands 61 meters away. That distance is 61 meters. Now, if we start kind of analyzing our data for the two directions, we have constant velocity motion in the x direction, in the horizontal direction. So we could use a constant velocity equation. And you might know that the form I'm using here looks an awful lot like the long equation with acceleration, the one that, you know, if you add plus 1/2 at squared onto the end of it, it would look just like that. But the acceleration in the x direction is 0, so, you know, we wouldn't, that last term wouldn't be important here. Or you may have seen this same equation for constant velocity kinematics, and in which case you can think of it that way as well. And we do have all the information we need here to solve for time, because maybe we could say the final x position is 61, and the meters, and the initial x position was 0 meters, which basically I didn't even need to write, and the initial x velocity was 17 cosine of 47 times the time. Okay, so and that was meters per second. I kind of left that out. Okay, so basically we will divide both sides by 17 cosine of 47. And that's going to be the time. Alright, so that soccer ball is in the air for a good length of, well, let me check my let me check my calculation here. Oh yeah, that is a very long time for the soccer ball to be in the air. So I had initially typed it into the calculator incorrectly. I didn't use some parentheses where I needed to. So anyways, that should be 5.26 seconds, which is an awful lot of hang time. And yes, I know that's more significant figures than either the velocity or the range, but it's better not to round, especially when solving problems for WebAssign on intermediate. You shouldn't round significantly on intermediate steps. Alright, so let's go over here in the y direction, and we're going to deal with some accelerated motion here. So the question was, how high was the building? So All right, so the constant, or the acceleration, the formula for position, accounting for acceleration in time, we'll use that. The long one, as a lot of my students like to call it. And we now have all the information we need to solve this as well. Because I think a good ending place for us perhaps would be to just say, hey, the final height is going to be 0 meters, and the initial height is the one that we are desiring to solve for. And we know the initial, I think I'm going to start running out of space here, so maybe I can move all of this stuff just a little bit. Let's see. Yeah, I can move it all down there. All right, so that gives me a little more space to work here. So our initial y velocity was 17 sine of theta. 17 sine of 47 degrees. Multiply that times the time, which is 5.26 seconds. And this 1/2 negative 9.8 times t squared. And I am treating it as up as the positive direction, it's down as the negative direction, so that's why this is negative. And also being a little cavalier with units here, because that's meters per second, that's seconds, that's meters per second squared, and then the time will also be in seconds again. Everything dimensionally consistently works out to meters for each term, so that is what we want. Anyways, 5.26 seconds squared. And basically all I need to do now, I'll go ahead and move this y sub naught over. NAUGHT is what I'm saying there. Another word for initial or 0. Let's see, 17.40 or 17 sine of 47 times 5.26. By the way, if you have crazy numbers come out, check your calculator, make sure it's not in radian mode. You need to be in degree mode here. 0.5 times 9.8 times 5.26 squared. And you do need to make sure that you subtract or something of that nature. So when I did all that, I got negative 70.17. And the negative signs would cancel out. So that's how that would work. So we're just using kinematics equations. You just have to make sure you keep your x and your y directions separated. Hope that helps.